My name is Russ Festino. I'm a technical evangelist for Algorand. And we got a great session on tap here for building with Algorand 2.0. Everything you need to know. How does that sound? Pretty good? Algorand's all about borderless economy, borderless opportunity, and Algorand is defining the standard for blockchain technology. I honestly believe that. The important thing here is I got this information I'm about to share with you from the China Blockchain Report 2019 and 20. And blockchain is not the future, it's the present. And so blockchain's usage is really hitting a lot of different verticals. And really the primary use case for blockchain is to maintain the integrity of data. So in China, this applies many ways, and really worldwide, it applies many ways. In the medical field, for example, having records accessible globally. I was at a doctor a couple of weeks ago, a new one, and I'm spending a half hour trying to fill out all the information about my medical background, and it's the same time. Every time you go into a new doctor, you got to do this, and I'm just sitting there, shaking my head saying, man, there's a better way. I know there's a better way with blockchain to do something like that. And, I even talked to the doctor about it when I got in there and had my exam. So I was, shedding some light on some new technology to an old problem, right? And then also, folks aren't always able to provide that information. Maybe they're disabled of some sort and they can't, articulate their, meds that they've been on, or maybe they have a hard time writing, that sort of thing. So this has been a problem. Another problem in the past has been charities. Sometimes the funds have not gone in the right spot. Red Cross, for example, misused funds back about a decade ago when some of the earthquakes had hit. With blockchain, you've got a immutable ledger, right, that shows all the transactions and the to and from accounts and that sort of thing. Automotive industry, I think used car salesmen on this one, lack of trust, lack of good records. That seems to be an area that's ripe for blockchain solutions, especially in the way of used cars. And then the study went on to say, telecom is another big area. You got a lot of identity theft going on, especially abroad. I was planning a trip to China a few months ago, and that never happened. But, my IT guy, made sure I was up on, all the different technologies, VPNs and password programs and all this kind of stuff. And so it was an eye-opener. Because they end up getting your phone number and then they end up getting your identity basically. And then also telecom needs a way to switch between networks, and roaming when folks are moving about. And this is a great way to try to incorporate some of this technology on blockchain as well. And then the food industry as well, the whole supply chain, where does the food come from? Where does it go to? These are things that could be tracked and helped, the masses in terms of, what's going on there. So these are just some really good examples that they really spelled out quite well. If you come across it, it's the Forecast Insights source. This is where the PowerPoint is today. If you want to take a picture of that or just type it in, I'll wait for a minute or so. And all the code I'm going to show is up on our developer site, and I'll kind of show you where that's at as well as part of the demo. And so, let's build a blockchain solution, right? You're already, know it's going to be good. It's going to help a lot of different folks. I know you've had some experience with the other blockchains. Anyone else that has joined, transactions in 10 minutes. What's up with that? It doesn't really lend itself too well for point of sale type scenarios. Forks, right? This also happens in some of the approaches where mining is used and building blocks that way, and that could cause some performance problems and vulnerability to denial of service attacks. If you are a proposer on a block and your identity is known ahead of time, that is then subject to denial of service attacks. And so again, not a very good thing there. And then, mining, is going on with some of the other blockchains, really high in energy consumption, very, very wasteful. It's not green at all. And then, what about the tools, right? Are there SDKs to develop with? A lot of developers really need, the first thing you look for is if a product's got an SDK that you're going to be creating a solution for. How about Swagger files? These are files that provide the definitions of all the REST API endpoints and being able to do programmatically really from any language that has the ability to do a REST-based interface, and pretty much all of them do nowadays. And then also, what about the docs? Good docs go a long way in ramping up and getting and building solutions. So we'll take a look at all these as we go through this session here. This is the agenda. We're going to go over Algorand Inc. At first, and then we're going to take a look at Algorand's core protocol, as well as start digging into 2.0 and then some of the developer type tools that are available. And even if you are not a developer, it's good to know to be able to talk to these at events you might be running. Maybe you got, or you had a speaker coming into a developer audience, and it's good to at least get the messaging right, as well as, some of the demos I'll do at the end here too. So here we go, Algorand Inc. overview. We have a star-studded cast here. Sylvie Macaulay at the top there is the founder. He is a Turing Award winner. And a few other prizes as well. He's an MIT professor. And a lot of his knowledge on hashing algorithms went into this product. Really great CEO, COO, and really this top line cast here on the Algorand leadership team. I just really feel humbled to work for this organization with all these folks, and everyone is just so nice. I've been working now almost a year with Algorand, and it's been a fantastic experience. All right, so now a little bit of a history lesson here for what's been going on with Algorand to date. Well, we were founded, of course, back in January 2018. And then we started right away from the get-go. We created SDKs, in Java, JavaScript, Python, and Go. Also, there's a C# community SDK now as well. Now we've got SDKs, so now we can start building solutions, right? And then we had TestNet introduced right around that same time, and we actually went MainNet in June of 2019. And just 6 months later, Algorand 2.0 released with numerous new features and use cases that are unlocked with those features in the layer 1 protocol right on the blockchain. So that's where we're going to be focusing most of the night on. And to date, there's been 5.4 million blocks, as well as 700 nodes in the network. And organizations are launching out now Algorand. The key areas of use are DeFi applications, initiatives that bridge gaps between traditional DeFi space and central bank digital currencies, but there's many, many more. And you can see here, even John Hancock has got building on Algorand, top networks, as more recent announcements, and then also Tether just announced doing some stable coins on Algorand. So we'll talk a little bit more about that as well. With Algorand 1.0, we had the foundation set, right, for layer 1 platform benefits. Minimal compute power required. You can even run a node on a Raspberry Pi. That's how efficient it is. You have a secure blockchain network with inherent protection against protocol network attacks. Lightning fast speeds, right, 1,000 transactions per second. Blocks are built in under 5 seconds, and the important point there is scales to billions of users. You got immediate transaction finality and really best-in-class tools for the key features and functionality built directly into high-performing layer 1 protocol. So that's kind of like where we started. And, we also believe that more is needed, right, when we transition from what is possible, what's a necessity. So Algorand has cutting edge foundational protocol. However, more important is what's just come out with Algorand 2.0. So we're going to share some of that right now. So what we have here, layer 1 assets. This is basically organized, and organization can easily create their own assets with double spending protection guaranteed by the protocol, just like double spending is inherently protected, on the blockchain itself for algo transactions. But you can create any kind of asset you want. Say you got a game or something and you want to do tokens, you can create tokens for the game and use the Algorand standard asset feature. That's exactly what they did for stablecoins with Tether. They used this particular feature to create that particular asset. So you can make your own coin, if you want to, on layer one, and it's fully supported through what's referred to as Algorand Standard Asset, or ASA. And then we get into atomic transfers. Transactions can be grouped together. Either all transactions in the group are executed or none of them are executed, kind of analogous if you're familiar with any kind of database work or SQL Server or anything like that. That's a transaction in a database sense is just that. There could be several pieces to it, but if any one of those fails, it rolls back to the way it started. So same type of thing here with atomic transfers. That's a good answer for, not knowing the trust factor of people that you are doing transactions with. So you don't have to trust the person because it all comes out in the wash with atomic transfers. It all goes or none of it goes. And then finally we get to smart contracts, which is the Algorand smart contracts and layer one, referred to as ASC1. These are small programs written in assembly-like language that can be used as a replacement for signatures within a transaction using TEAL, a transaction execution approval language. And so that is the kind of high-level overview. We're going to drill down into these in subsequent slides, but at least that kind of gives you kind of an overview. There are some good use cases out there right now. Asset block is great for using tokenizing real estate assets. So say they own a hotel and you want to be able to parse that out to many different owners. Well, you can do that now very easily. And that's really what the foundation of that company is doing, is multiple ownership of real estate. So it's a very cool idea. And Tether, I mentioned, is on the list now there with stable coins. PureStake is a great API provider and service. I'll be talking more about them too as well today. You got World Chess plans for hybrid IPO and Algorand blockchain, and Flipside Crypto, enabling analytics for decentralized apps on Algorand. We'll get to Algorand's core protocol next. This is great to kind of spend a little bit of time if you are presenting this to audiences that are fairly new to blockchain, which I'm seeing to be coming across more and more, especially at these professional developer conferences and meetups. But anyway, it works like this: one by one, the blocks are created on the blockchain, and really a block can be analogous to a record in a distributed database. And even a more basic definition of a blockchain, if anybody's really new to it, is I kind of view it as a read-only database that's write once. Anytime you write a new block, you're recording transactions, and now they are immutable and they're on that blockchain. And so the ability of having a ledger, mutable ledger, is very valuable in a lot of different scenarios. But how are these blocks generated, right? You may have heard of forks, you've heard of proof of work perhaps. Well, we don't use either of those. And what we really do is just use pure math to go ahead and do it. And this revolves around the Byzantine agreement. So let's go through that a little bit. And for those that are not familiar with it, basically the Byzantine agreement is, getting a consensus. In other words, there's a messenger that goes all the way around this kingdom, and they got to talk to all the generals, make sure they got all the supplies and ready to attack. And if they get a complete consensus and they're good to go, they'll go ahead and attack, and they'll be a success. If for some reason you get a partial messaging completed and only half of the generals actually get to communicate on this, and they do the attack order, you're doomed for failure. And so basically, Sylvie McCauley, as I mentioned, our founder and Turing Award winner, got to figure it out. You really don't need everyone to participate. What you need is a representative sample. And then it comes down to basically size versus cost. Many functions are, double the network, double the size. And then there's some quadratic, functions out there in terms of size versus cost. With 1 million people, there would be like 1 million squared in terms of the cost. So it really gets out of control. So that is a big thank you there to Silvio for getting that all figured out. So we're basically using a great sample representative sample to do the block building. And then that gets down to the actual name of our consensus. It's called pure proof of stake. And the consensus is public and permissionless, so you don't need any kind of authentication to log into it, and it's public so everyone can see it. All users can participate in consensus. All you need is some algos, and you could be in the voting process. Blocks are confirmed by voting, like we talked about, and every token carries the same voting power. Now, the important point and difference from coming from other blockchains is there's no need to delegate or bond, and there's no, mining that needs to be done. In terms of delegate or bonds, sometimes you might hear a delegated proof of stake. And that is where the individuals are known ahead of time, or delegates that would do the voting on the blocking. So they are known ahead of time, so they are subject to denial of service attacks. Whereas with pure proof of stake, only the voters are known after the fact. So there is no potential for a denial of service attack on those. Bonded, same thing. It's a select few, right, to put money or a bond into the blockchain. They misbehave, they lose the bond, but it sounds good in theory. But if you put a bond up for $1 million and you stand to gain $1 trillion by being a bad player, then you're making out in it. And again, you're subject to a denial of service attack. And right now, what we have, our nodes are really a minimal compute required, very tiny, very efficient, very fast, and really good stuff here in terms of the actual protocol. And here's a diagram. Basically, there's going to be 3 steps. You're going to do a propose, and then you're going to do a confirm, and then the block is then written to the chain. And that's exactly how that works. And then, so sample committee, once again, it's from a random set of users, and the committee agrees on the block of transactions. Every member verifies transactions and digitally signs it. And then, boom, there you go. Now it gets written out to the chain. There is a good video up on YouTube on our Algorand channel. I suggest you check out a lot of the videos up there. This one in particular goes over the core protocol. You do have the deck, so you have the link, or you can take you scan that barcode right now, and then it'll come up there, and you can mark it for later viewing. And it's a very short one, about 5 minutes, but it really does a great job of describing it. And if you are doing a live session somewhere and you want to describe the our protocol, this is a great way to do it. Just play this video, and this will give you a very good definition of the protocol. This is a little bit more of an advanced view for the same thing on the Byzantine fault tolerance. Basically, you propose, you get the soft vote, and then you certify it. But here's the kicker, right? This whole process is done in 5 seconds or under. And so that's another good set of slides to kind of show on that. So let's get into Algorand 2.0 a little bit deeper. Again, what we're going to cover here is a drill down into Algorand standard assets, atomic transfers, and smart contracts. So with ASA, we've got some exciting times ahead here with this particular feature. And it provides a standardized layer 1 mechanism to represent any type of asset and right on the Algorand blockchain. So assets can include things like fungible assets such as currency, stable coins, utility tokens, non-fungible assets such as tickets, right? They're look the same, but they're not the same because they have different values, different seats, different sections, that sort of thing. You can do restricted fungible assets as well, such as securities, restricted non-fungible assets such as licenses and certifications. And then asset issuers or specified delegates can optionally have the ability to freeze an account if you set up the account with a freezable option set to true. And then also the account's ability to transact with their assets and claw back their asset when required. So a lot of capabilities built right in. With ASA, any user can create a new fungible token. The potential supply of the new token is set at creation time. And then there's various roles. You have a creator role, you've got a freezing role, removing, destroying, and clawback roles, and you have different addresses you can assign for each one of those types of functions. So very flexible in terms of how this thing is designed. Tether announced stablecoins, putting that onto our blockchain using this feature right here. And basically, the problem they're solving is that one of the problems of cryptocurrency, it's very volatile in terms of the price from day to day. The easiest way to kind of counter that is something that's pegged, to an economy, and Tether is pegged 1-to-1 with the U.S. dollar. So this is the easiest way that a stablecoin can be developed, is using this particular feature. And as the name implies, a fiat currency needs to be deposited as collateral for the fiat collateralized stablecoin to exist. And from there, the tokens are issued at the 1-to-1 ratio against the collateralized fiat currency. So really great idea. I don't know if you've used stable coins or are familiar with those, but that's something that's really becoming very, very prevalent in the blockchain space. Then we get to the next feature here, atomic transfers. So they offer a secure way to simultaneously transfer the number of assets among the number of parties. So specifically, many transactions are grouped together, and either all the transactions are executed or none of them are. It's like I said before, it's analogous to database transactions. And so this is a great way, if you're trying to do a transaction between, Bob and Alice and whoever, and then make sure that all those transactions are done, and then it's good. Otherwise, none of them will happen. Some applications for atomic transfers, things like matching funding, debt settlement, decentralized exchanges, changes in complex, trades. Then we get into smart contracts, right? So smart contracts today are slow and expensive, but now we have Algorand smart contracts, and the ASC1 are layer 1 smart contracts that automatically enforce custom rules and logic, typically around how assets can be transferred, including ASA assets or native algos. They are complex economic relationships made up of basic transaction primitives written in a new language called Transaction Execution Approval Language, or TEAL. So examples of ASC1 contracts that can be written are escrow accounts, loan payments, limit and stop orders, subscription payments, and collateralized obligations. So there's two basic usage scenarios. One is a contract account, and the other one is a delegated signature. So when used as a contract account, the TEAL code is compiled, which returns an Algorand address. The contract account address can be sent algos or Algorand assets from any account using a standard transaction. So when sending from a contract account, the logic in the TEAL program determines if the transaction is approved. And contract accounts are great for setting up escrow style accounts, where you say you want to limit withdrawals, or you want to do periodic payments, that sort of thing. And then you can also use TEAL to do delegated signatures, which essentially means that you sign the TEAL program with your private key or multi-sig keys, and you can save the logic structure to give to someone else to submit transactions with your authority. So the TEAL program can limit the amount of authority that you delegate. For example, you can create a delegated signature that allows a utility company to remove up to X algos every 50,000 blocks from your account. And I got demos on these as well. We also do have the ability to write smart contracts in Python called PyTeal. So it's a kind of a layer abstraction over the top of TEAL, but much simpler to use. So we have a great Medium post out there. If you go to medium.com/Algorand, you will see all of our posts out there, and we actually have a developer channel there too for Algorand. Then again, another video I can recommend is there's a video on TEAL, and boy, it's really great. It's about 5 minutes. Brian did it over at Algorand, and really explains very nice stack-based language of Teal and some of the basics on it. So let's continue on here and talk about these things, all our different networks. So BetaNet, TestNet, MainNet, worldwide networks all over the globe. And we actually created a BetaNet back in November when we launched the 2.0 version of Algorand. So that's going to be used for new technologies. TestNet and MainNet mirror each other. So if it works in TestNet, the theory is it should work in MainNet. And so those are always the same in terms of the same code base. Then there's something called private networks that you can use in any of those environments. And basically, a private network is nothing to do with privacy. It's more of a personal network. It runs right on your own machine, your own laptop, and it's nice for creating an isolated, consistent environment. Of particular use is probably more with BetaNet, where things are volatile and they change often. If you want to create basically a stable snapshot of where you're at with BetaNet and not be impacted by any updates coming forward, you can test that all with PrivateNet. So again, the private network is a developer-only tool, and really just think of it as a personal network is your best bet. Then we got some other tools here, Algo Explorer, Goal Seeker. I don't know if you've used these before or not, but basically Algo Explorer was the first one on the block, and then PureState created another one with Goal Seeker. They both have different features, so play around with both of them, and if you don't see a feature on one, maybe it's on the other. I know Algo Explorer, for example, works with BetaNet. I'm not sure. I do not believe the PureState one does. And there are other cool things about each one of those. So we'll show you those today a little bit in our session we go through. So now the next section here is let's talk about local nodes and standup instances. So you can create your own node, certainly, on a Mac or Ubuntu or other Linux distros, including your Raspberry Pi, like I mentioned. One problem is it will take several hours to do the initial sync, and could be rather lengthy. And if you are at a hackathon or a workshop, that's really not a good alternative. I mean, maybe to use it afterwards, after that's over. So there's a couple other options. One is a PureState API service that provides index and archive nodes. So those are options you can set. They're by default, they are off. Even in a local node, you can set those on by modifying the config file. And you can access the SDK code on platforms that do not have nodes, for example, Windows. Although I did see a post, I've been talking to someone on LinkedIn, they did actually create the first Algorand node on the Windows platform. And so that'll be interesting to follow how that evolves. The sandbox is really the preferred approach right now, I think, especially more so in the development environment, whereas PureState does have development environment, but you can also extend that right into production. It's a pay service in production. TestNet is free, but some organizations don't want to be involved in creating nodes, so that's really a great solution. And then they want to go to MainNet with it as well. So that has some promise there as well. But the Docker image is all you need for the sandbox. And it's, again, not for production. And the way it works is it takes a current snapshot from AWS of the network and gives you that snapshot. And there's no sync time, zero sync time. You're up and running, going high speed, doing development work. The thing you cannot do is go back on the blockchain and look up stuff that happened prior to that, because it does away with that sync process. It just goes forward. And there is a great area on our developer.algorand.org site under the setup, facilitates and shows you all of these options, everything from Windows, the workspace setup, to connecting to a node programmatically and creating your first transaction. We'll take a peek at some of that stuff in the demo when we get to that part of the demo. The other thing too is, as far as Windows goes, the sandbox does work on Windows. What I had to do was enable the Windows subsystem for Linux. It's a Windows setup option, number one. Number two, install Docker, of course. Number three, I think I had to install Bash, and the way that got installed is actually just downloading the Ubuntu image in the store, and I believe that automatically installed Bash, and then I was able to select that in my terminal to run all my command line tools like goal and all that kind of stuff. But that's all built right in. So the sandbox is analogous to creating your own node and having it synced up with all the tools. And it's just going forward is the only difference, nothing behind. So some good stuff there. This is just a snapshot of, you can all you do is just clone the GitHub repository and then go into your terminal and then do a /sandbox-h will give you the help that you see here, or the up command will actually start that instance up. And then you have a common URL and token that's provided, and it's all documented on that GitHub site. And then there's also a Medium post there, link at the bottom on it. So speaking of which, Algorand DevRel is our developer-related repository. I have a hackathon instance out there. I'll show you that. It's great for kind of getting started in a workshop kind of fashion. There is, Raspberry Pi set up on there, as well as a good chess example, the game of chess. I always love playing chess, so that's pretty cool how that works. That actually utilizes, for example, the archive and index feature we talked about, because it's going to be doing the search across the blockchain, for example, when you're trying to pair up people to play. So you put a request out that you want to play, and the app does a search for anybody else who's got a request to play, and then once it finds it, it goes ahead and gets the first hit, and boom, you're off and running and playing. So very cool thing to take a look at. You got DevRel on Medium, and so every Tuesday we publish our articles, like I alluded to. Go to Algorand/Algorand/developer, see developer-related ones. We just recently announced building your own code. I've got some posts I just put up on recent hackathons that we did with the winning teams and some of their solutions they built. Very creative folks out there. Smart contract content, atomic transfer content, transaction content. So great resources, the bottom line there on Medium. We're also going to be starting to post more to our own website. We'll have an articles piece to our website as well. And also on our website for that's on the developer site. And on the developer site, we're also going to be incorporating more features like tutorials. We just actually launched this version of the developer site probably about a month ago, and it's already very rich in code samples and features and the SDK references, all done really great. All right, so developers, APIs, SDKs, command lines. So this is what our developer site looks like. Very nice getting started landing page. Exploring features, you got how to run a node, all this kind of stuff is very easily findable along with reference docs. We'll show you that live in a second, and then here is the SDK functionality with the languages supported currently: Go, Python, Java, JavaScript. There is a Rust SDK in the community. There's a community page on the site. You can find out all this great stuff. The Rust one at the moment does not have any of the Algorand 2.0 features in it. The C# one does, and the C# one I've actually used. It's rock solid. I really gave it a 2 thumbs up. It's also done in the .NET Standard 2.0, and there's a snapshot of the GitHub for that one. And actually, this individual here, Riley GE, he created this through the Developer Incentives Program on the Algorand Foundation site, and got paid handsomely for developing this. So that's another thing to tell developers about, is the developer incentives that we have up on the foundation. Lots of good incentives there for developers to create solutions related to the Algorand blockchain. So Swagger files I had mentioned early on, what this is used for is basically creating the definitions of the methods and properties for all the different REST API calls. You can kind of see the code in the upper corner over here, and that is where we have the, you can see the description, the title, the everything that pertains to that particular file. Also, the Swagger files are great for importing in API testing tools like Postman, and all the definitions and all the calls are already set up for you with the parameters that are needed, and all you got to do is plug in the values. So that makes it real easy. So let's go ahead and bring up first the developer site. start building is the place to really point people to first, right? And where it does is it brings you into this sequence. So you have the workspace set up. It goes into, installing your own node. You would get these tools. Goal is our command line tool. KMD is a command line tool for wallets, and the algo key can generate accounts, for example, without the need for wallets. You can do just standalone accounts with that. And it describes all of these. Then goes into choosing a network. This then talks about the networks that I talked about with MainNet, TestNet, BetaNet. And then how do I obtain an algo address and token? Well, there's a few different choices, right? You got the third-party service with things like, here's that community page project I talked about. So there you can see Pure Stake for API services. There's the couple of community SDKs. There's a sample algo wrapper in terms of support, JavaScript and TypeScript. These are all community stuff. PyTeal we talked about. You've got some framework components. And then some applications, right, are on this particular community project page. So that's kind of a nice thing that we put together there. And then you got the Docker sandbox, and this really is the easiest and quickest way, and I would always recommend this to any developers that are just starting out now. This is fairly new. This evolved from an internal hackathon that we had at Algorand, as did the C# SDK. I actually did a presentation on that, and then we had the community follow up and finish it off. And then also there was a couple guys at work, Will and Sam, they forged forward with building the sandbox, and now that became a full-blown product actually within Algorand. Next step is then to connect to a node, and this is where we get to the code. Now all the code samples are in all the different languages: JavaScript, Python, Java, Go. And then down here you have the ability to, this code here checks a node status. So the first one is going to connect and create an instance of your client. So that would be like right here, make clients. Now this algo client is able to then do actions and method calls and functions. This, for example, is a call to get the status of the node and so forth, right down the list. And then the important thing to point out is at the very bottom of each one of these pages is the completed example. So there is the whole example in language of your choice to connect and get a status and what the versions are and all that kind of good stuff. So, and then this next one here is a great way to get started with just doing a transaction. It goes into the step process here. You get generate account automatically. You can go ahead and get the passphrase. This here is in Go. And then you print off the address, which is part of the account that you created up here, and print off the passphrase. So what you want to do is, after you create an account, you want to copy off that account address and then go out to the dispenser and dispense funds to that, so that you can do transaction, because there's going to be transaction fees associated with those. And when you get to MainNet, by the way, it's less than a penny, for transaction fees. Then you want to sign the transaction, and then you want to submit it. So signing is done with the sign transaction method here in the case of Go, and then send raw transaction is what you want for that. So each one's a little bit different in terms of naming. JavaScript, you would use the, you want to come down to the completed solution here for that, sending a payment. Right, and then you have there send raw transaction for that one. Python, you got is going to be using this transaction method there, and so forth. So the other thing to point your folks to is this explore features area. So here are some creation methods. For example, if you want to do a standalone account, you just click on the right. There's the table of contents. It brings you right down to standalone account. And this is the code to generate it in all the different languages. And then you have information about transactions, including offline transactions. So that'll write out to a file, and then you can read in the file to go ahead and sign it, that sort of thing. So that might be used in a more secure manner. A lot of information on assets, Algorand standard assets, atomic transfers, and smart contracts. So that's some great reference docs. So that's the current state. That was a good V1 of our portal. We're working very hard at that. The DevRel team is to come out with our new version of this, which should be out pretty soon. I don't want to give any dates, but it should be out pretty soon. Blockchain core functionality. And to do that, I'm going to bring up a JavaScript demo here. And first and foremost, I'm going to show you the sandbox. So this is where I am running and accessing my node. And what you can see here up on the site when you download it, you'll see the values. I'm going to show you in the code. But for example, right here, I can just go sandbox and then use maybe our goal tool, node status. Right now, it'll come back. It tells you that zero sync time's the important one. That's what you want for transactions to work, because then you're all synced up. But in the case of sandbox, it should always be 0. And then gives you more information in terms of the next round, or this is the block number. All this is important too. Know which network you're on, and so that's a pretty cool way. And then there's actually a tutorial. If I bring back this, actually all the help commands here, you can actually see that to get a tutorial, just put in sandbox and then introduction, and it'll go through and guide you right through step by step. So very, very cool tool for a developer. So I have that up and running right now, and I'm going to use that in my demos. Java example, and I'm just going to kind of run this so you can kind of see the functionality. So here is our page. There are several, I like showing this because there's several like core functions here, things like getting the latest block, generating an account, recovering an account from a mnemonic. That's very useful, right? Because it's difficult to carry that private key around or expose it, and the mnemonic is a bunch of words, and it's a lot easier to copy and paste that, or even type it if you had to restore your account. Then we're going to submit a transaction, get the account details, and get the information on that to transaction. So first things first, let's get the latest block really quick. You can see it snap right back. Let's go ahead then and generate the account. And now you can see it got populated up on top. So if you take a look at the 2, right, that's where we're going to send it to. And this is the new account that we just generated. Here is the account mnemonic that's associated. And every transaction has to specify a range of your rounds, the first round and the last round. I think it's going to be about 1,000 different is what that can be, a span 1,000 blocks. So we've got our account generated. So let's go ahead and get the account details. Now we can see the account address. And what I'm going to do now is pop out to the dispenser that I talked about. And we're going to dispense some funds to this account. So anytime you create a new account, this is the process you got to go through when you're creating this. Now that was a success. So if I come back over here and then go ahead and recover this from the mnemonic, there you can see that this account is now loaded up. And these are in micro algos. So if you have 1 million of these micro algos, that'd be the equivalent of 1 algo. And so what that dispenser did is it dispensed 100 algos to this particular account. So now what we're doing is we're ready to submit a transaction. So we're going to send this amount of algos from the from account to the to account. And there is the transaction ID. Now I could take this transaction ID and go out to some of those tools that we had talked about, like here, the Blockchain Explorer, for example. And here, as you could search on address, transaction ID, block, asset unit, or asset name. So we'll go ahead and paste this in, and you got to be aware of the drop down here. We're in TestNet. So let's paste that in again and then do a search, and we should see that transaction just came up moments ago. And so that is pretty cool right there. So, and then you can actually drill in on the sending account. This is the new one that we just created. You can see where we transferred 100 algos in when we created it, and this was the 739 number that we saw get actually transferred. So this is a great tool. The other one PureStake did, Goal Seeker. And this one here, you can do a search by, asset ID and similar, and you can actually see the all the transactions listed right there. And let's go ahead and do a search here on that other one. So this is pointed to TestNet. Go to the transaction. There's similar information that you see right there right now. So very good tools when you're developing and utilizing. So getting back to the demo now, what I'm going to do is get the transaction from the account, and there's a note field that you could do a customized structure to, and we have like a person object in the code here that gives us the age, eye color, and all that stuff written to the note field. So that is the demo, and then if you're showing this to developers, you can see all the code right here. This is this is the token right here for the sandbox. It's all A's, local host, and there's the port number. And if you were doing a hackathon and you wanted to use the hackathon instance, just uncomment those lines. They'll give you the special token and server we have set up for that, and then comment out these, and you're off and running with that. There's also code in here to get set up with pure stake, so you just again uncomment that, and it'll go ahead and give you the pure stake token right here. And they need a header for that, and then also if you create your own node, you just copy those out of your folder and your data folder where those are at, and the startup instructions show you how to do that. And then the calls, right? So this is where you go ahead and create the instance of these SDK. There's your client. There's where you get your account information. The next one here is getting the block status, so it's going to call the status function and the block function. This is the code that generates the account. This goes ahead and gives you your mnemonic, right? That then gets put up on the display in that app. This is how you recover the account from that mnemonic. So we're going to use the mnemonic to secret key method. This is going to submit the transaction, and we're going to encode this person object here and slap that into the note field, which you see right there. Then we come down over here, and you've got the sign the transaction and then send it out. So the send does the broadcast. That broadcasts it to the network. And that's when you know it really works. When this comes back with success, then you've done it. And this retrieves that transaction, so it's going to go ahead and get that TX ID that we spun up there before. And then now to have it, and then we're going to decode the note field and then display that in the app as well in that field. All this for a couple hundred lines of code. And usually I say at this point, and the crowd goes wild, right? And they go crazy, right? So I think you can start seeing how easy it is, you know, even if you don't know coding, and just following the basic calls and functionality, that is pretty cool. So this is actually, these are in Java, and this is going to be the first one I could show you here is that create accounts, right? So this you would run to generate your accounts in Java. And so let's go ahead and fire this up. And I'm going to hit my breakpoint here this time. And now you can see down below there's address 1 that got generated from this call. And there's the address, get address method to get that one displayed. And here's the mnemonic phrase that is done with that one. So I'll just run this to completion. So at this point now, what you would do if you're doing this kind of code is copy each one of these addresses and then go out to the dispenser and dispense funds to each one. And then also copy off these passphrases because you're going to need these to recreate your account in the code samples. And I'll show you that next. So now if I go to, for example, let's do this transaction one first. And I'm going to fire this up. And so hit our first breakpoint again. There's the address and token for the host and the token value. And then here's the transaction method, new transaction. And we're going to get the address from account 1 is going to be the sender. And then we have a receiver account specified up here in the code right there. That's going to receive it. We do not need to have the private key to send to the receiver. We only need the private key on the one that's sending it because they're going to sign off and send that transaction. And so the signing is done right here. So this creates the transaction, which is originating from the original address. And then here's the transaction, and we're going to sign off. And now I've got a signed transaction. And I'm going to show you this now. We're going to create an account. We're going, like I just did. we're going to basically go from that step forward. So I've got my accounts created. I'm going to restore them in the code and then create a new asset. We're going to configure the asset management functions. We're going to opt in to receive an asset. We're going to transfer an asset, freeze an asset, revoke, and destroy. So let's go ahead and get going here with this demo on assets. So I'm going to, again, just, I got some breakpoints set in the code so we can talk to those. But the very first thing we're going to do is create the asset. And I've restored the account. So you can see where I restored the account. Those are the mnemonics I mentioned to copy off. And then now we're going to feed those into the account function. So it's going to do a restore on that particular account. And you can see the addresses I printed off. So I've got 3 addresses. The first account, which is going to be the creator account, begins with BJ. Then this account 2 begins with HV. And the last one is QU in that account. So, oh, I'm sorry, that's confirmed and round. The asset ID, I got to step over that line, is this guy. Okay, I was searching on the block. Okay, so now let's do it. So we can go ahead and do a search on that. That looks better. So now we see here is I've got the actual creation, and you can see they're all set to HV. All of these are. If I go a little bit down to the next instance, this is the creator piece. And then this guy also owns now, we set it up for 10,000 of these new assets. And anybody that holds this particular asset, you will see this little piece here that it just has the creator, the amount you have, and if this is frozen or not. And so now if we go back over to the code, you can see here, we're going to configure it this time. And this time what we're going to do is we're going to configure account 1 for one of the functions here for the management account. And so now if I go ahead and run this, and again, it does the same process. It submits a transaction, then it'll broadcast the transaction. And now if I go ahead and take a look at this, and I'll send this out and then do the search, you should see now that the one that begins with BJ has been changed. So now that's the manager key, and the HV is for the other 3. So that worked. And then this call here will get the asset information. It'll display it right down below in the output, very similar to what you just saw there in the Postman. And let's continue on now. So now what we're going to do is opt in to receive the asset. So we're going to say, okay, account 3 wants to receive this asset. So you're basically sending 0 assets to this account. And you just can't blindly send assets to any account. They have to opt in to receive it. And this is what does that magic. So once they're done, what we're going to do is do a transfer. And we're going to transfer the asset. So what we're going to do is we're going to transfer a total of 10 to the other account. The account 3 is going to end up with that particular value. So if I go ahead and do this, right, and then if we go take a look at our total here, I'll do another send. And you can actually see now the values over here. They're displayed. That's that one there. This will be this one down here. Now you can see I've got 10 less, right? The pool, the total is still in the creator account information of 10,000. But how many I hold now in account 1 is 10 less. Now it's 9990. Also, I forgot to mention, and when you are creating an account, there is a field for decimals. And decimals is right here. I've got it set to 0, so there's no decimal point. Here I've created 10,000 of these. If the decimal was set to 2, you'd have 100.00 of them. And so you can specify that kind of granularity too in the assets. Then I've got freeze the account. So I'm going to freeze the account, and then if I were to take a look at this through Postman, we see the freeze value is set to true. Now the next one we're going to do a clawback. We're going to revoke that that send we did originally, and we're going to claw back the 10 that we originally sent. So now I'll go ahead and do this, and what you should see once this completes is I'm going to go ahead and do a refresh over here and take a look at that account. And now you can see I've got all 10,000 of those back. So I recalled it back into this account. And then finally, now that I have the complete set of tokens, I can destroy it. You can only destroy if you have all of the tokens. And now there's some logic in here to say, okay, does this exist? And it's going to catch it, and it's going to say, no, it doesn't exist, and its fault returns back false. So that has been destroyed. Let's go ahead and bring up the group transaction one. All right, so now we're going to go ahead and create the first transaction with account A's address. Then we're going to create a second transaction. This one here does a transaction of 10,000. This one does a 20,000. And you're going from B to A, and this one you're going from A to C. But you want these all to work together. And so I'll go ahead and create the first transaction, create the second transaction. Then what I want to do is group the transactions and assign IDs. So these are the transactions. We're going to compute a group ID, and then we're going to use that group ID and assign the group ID to those the same group ID to those transactions. So now we know they belong together. So now we'll go ahead and sign this first transaction. We sign the second transaction, and then we go ahead and do the raw transaction. And now life will be good. So here we're concatenating these output streams into that. And there it is, confirmed in your next round. So that amount has actually been transferred. And then the final demo we'll go through is the one for, let's do one of these smart contracts one. Let's do the delegate one. And I'm going to go ahead and start this up and run this. So here we're using our SDK to go ahead again and retrieve the mnemonic for the source account. And that's the one that we are going to be signing with. And so we're going to make this program sign with my account basically, and we're going to be able to delegate this program to other people, and whenever they use it, it'll be using basically this signature. And so that is what I'm going to show you next. So here's the program that it represents int0. So int0 in teal is represented with these hex values. That is always going to return false. Is the intent there, and so this will fail at the end, but it's a sample program. And these are this can be generated with the goal command from your teal program. Then we'll go ahead and create the logic signature. So there's three different ways you can have signatures. You can have individual signatures, you can have multi-sig signatures, in other words, multiple accounts where there's a threshold. So you have 5 accounts grouped together, and 2 of them have to approve the transaction. Your threshold will be 2. So if any 2 of those approve a transaction, then it is signed and sealed and delivered. Here we're having our program do the signature, and that's what we're setting up with this statement. And there I'm going to go and sign that with the LSIG. I'm going to do a new transaction and fire it off, and then sign it, and then send the raw transaction out to the network. Now, here you see rejected by logic. That's because when it went to do the raw transaction send, it says, no, this returned false, from this program. So, it basically, all teal returns true or false. And in this case, it's returning false back because that's what int0 does. So it's not going to send it.
You enter your mnemonic here, get started. So let's say create new asset. Not frozen. 2 decimals. And for the address, I need to quickly grab my address.
So this is great. This is a UI basically for what I just showed in the code.
Yes, yes. So you set all the variables you need, hit create.
Nice. I'm liking this.
There we go. So like you can click on the TX hash, see it went through. Click on the asset ID. The asset can take a couple seconds to load on Goal Seeker because they're indexing it. But yeah, everything's set the way we did it. That's all good. So now you see that it popped up here in my assets list. So again, this is just all the information we just said about it. And since right now I am all of these addresses, I have all the permissions on my address, I have access to run all of these management commands. So let's say I go to modify and change maybe the freeze address. So I no longer have the permission to freeze. So let's pick a random Algorand address. So it can be our new freeze address. So this guy. And we freeze, confirm. Cool, it went through. And still indexing that.
What language did you write this in?
So the front end is written in Angular and TypeScript, and the back end is Go.
Okay.
Yeah, it's all open source. You can visit it at github.com/mangodev-io. And we have the Mango project over here, so it has our front end and our back end. And it all runs with Docker, so there's no complex changes to make. You just Docker compose everything. Anyway, so we see that the freeze address changed over here. So that's cool. So now if we go back to that, you can see I no longer have the option to run the freeze command because I'm no longer the freeze address. And let's say I just want to finish off with destroying it. So let's say go here, destroy, yes. And
how'd you get the name Mango for it, Mango Dev?
So we used to call it the Algorand Asset Manager, which was abbreviated AAM or AAM. And the word AAM in Hindi translates to mango.
Wow. So. Interesting. I like mangoes myself. I think it's a great name.
Oh, yeah, absolutely. Cool. So the destroy transaction went through. You can see that everything has been unset, and the asset will give you a 404 because Goal Seeker stops indexing them once they get destroyed. And yeah.
Nice. The crowd goes wild, man. Hey, it's a great job. That's very cool. And those are the demos. So in summary, we saw a lot of cool things here today. We saw, number one, an overview of the company and where we've come from, and really a significant amount of accomplishments in a short period of time with a great crew at the helm. Algorand's core protocol, we got a feel for how that works. Some of the new features at a high level, and then we went to more of a deep dive into the 2.0 version of Algorand. We covered all the different networks, BetaNet being very useful for new features. Local nodes and stand-up instances, we saw a lot of different options there to create a local node. You can use services like PureStake, as well as now the Sandbox to do development work in. Lots of APIs and SDK calls we looked at in the code just there in demos. So with that, I'm going to go ahead and call a conclusion.